So there are some things that we have to understand about space, because there are some inherent challenges that are involved in mastering space colonization or making it even possible. One is the vastness. So space is so infinitely large. You have planets, and in our solar system, we have 8 planets together with the sun and the many asteroids. They form our solar system. Then we have trillions of other systems that form up our galaxy, the Milky Way, and in the observable universe, which is the universe that we can see, just observe, there are about 2 trillion galaxies. And then you have clusters of galaxy groups. And this basically means that when we're talking about traveling between solar systems or between other parts of the galaxy, or even between galaxies, we're talking hundreds of thousands, even millions of light years, which means that the time it takes, if we were to travel at the speed of light, would be centuries and millennia.
Yeah,
Go ahead.
We know all of this only not because we've been there, because most of it's just based on telescopes. The farthest distance that we've ever traveled or that we've ever been is where Voyager 1 and 2 has taken us, with Voyager 1 currently being at 22.8 billion kilometers of Earth. And this is after 40 years of operation. The speed that it has reached is 17 kilometers per second. If you compare this to what we consider our current limitation, which is the speed of light in vacuum, that is not much, because that would be 300,000 kilometers per second. And this is also referenced versus Earth, so it's huge.
Yeah, so it's fair to say that we still have a lot of technological innovations to even break the speed of light or go beyond it to make space colonization a reality. And maybe more talking now directly about space, just for a short introduction. Many galaxies, ours included, are thought to have a supermassive black holes. So these aren't just black holes, but they're supermassive, they're huge. And the way black holes form is you have a lot of mass condensed into such a small, tiny space that nothing, not even light, can escape it. Each black hole has its own event horizon, where once you cross this event horizon, you cannot escape the black hole, even lights. Then we have dark matter. We know today that about 97 to 98% of all matter in the universe is dark matter, and we just do not know what it's made of or how it behaves.
Yeah, it also doesn't reflect light, so we cannot visibly observe it. So if we study the origins of the universe, it all starts essentially at the Big Bang, where elementary particles are tied together in a small space, and they then explode and expand into everything that we know today. The universe is still expanding. And the alternative idea is a big bounce, where you have a process between expansion and contraction, where the expanded universe at some point collapses because the gravitational forces take over. So the galaxies are not holding together anymore, which we call the big bounce idea. But in any case, we can actually observe the universe. We can travel back in time because the speed of light is limited, and because time is part of space in what Einstein said in Relativity. This is a huge field of research, and one that has not been fully developed yet.
Yeah, so relativity basically means, right, picking up on what you said, that because everything is constant in movement, we can really only measure things relative to our speed, relative to our location. So this makes it really hard to have absolute observations. Further, the understanding that we have today in the scientific community is not that gravitation is not really, doesn't exist, but that we have a 4-dimensional space-time surface, the curvature of which we call gravity. So gravity is merely a curvature in space and time. And because space and time are correlated This means that if we travel in space, we are also traveling in time. Makes sense, right? Time always moves forward, and we are moving through time. And another important fact is entanglement. And would you want to explain what entanglement is?
So some suggest that explaining dark matter is tied to explaining what we don't know yet, which is quantum mechanics. And both entanglement and superposition, which are the two core principles of quantum mechanics, are crucial for understanding much of our universe, is what is suggested. So entanglement essentially is enabling anything that is part of it to travel faster than the speed of light. Because entanglement means that two particles with an infinite distance between them behave the same way. And there must be some sort of connection in between them, at least to our current understanding, which is not that far, so that they can move into the same direction at the same time. This could also explain something like coincidence. It could explain randomness. So very interesting part. And we talk about something that is faster than the speed of light, and this might also become relevant when we talk about space exploration, where we need to cover a vast distance and thus need to be very fast to essentially do anything within a certain amount of time. The other part is superposition, and that's something that really messes with our reality, because things are not what they seem. They depend on who looks at them and when we observe them. And this even means that when we observe something in the future, its past is changing. So this could be connected to understanding spirituality and consciousness and how we look at reality. So very, very interesting to look at this.
Yeah, absolutely. Another aspect that is maybe important is a question that I'm sure everybody has asked themselves: do aliens exist? So we know that there have been many UFO sightings, the hype around Area 51, maybe the possibility that they're harboring aliens, patterns in cornfields. But as of now, we don't have any concrete proof of life on other planets, because for life to evolve and sustain itself on a planet, there are many conditions, right? You need to have the planets in question has to be in what is known as the habitable zone of the star that it's orbiting, meaning that there is a specific range in which the temperature isn't too high or too low. Then there are other things such as an abundance of water, carbon, and other factors that are important, such as an ozone layer or any type of atmosphere that blocks solar radiation. But given that the universe is vast, right, with millions or even billions of galaxies, each with trillions of stars, with multiple planets, the probability that there is a life form out there is quite high. But that doesn't mean that we could discover them. Maybe they are just too far away. Maybe they are just starting out as microbes. Maybe they already had a great galactic civilization that was wiped out, and all we have left are remnants. So these are interesting questions that will come more into question once we have really mastered space colonization.